Please tell me you're just being funny, right? No? Do you need something? No, okay. All right, let's try this again. Class?
Yes.
Okay, so we are starting my review for the exam. So Unit 5 exam. Okay? Unit 5 exam, so this is the multiple choice we're going to go through. I'm going to try and do as much as I can, step by step, every single step. Okay? Sometimes I might abbreviate what we're doing, and then I'm going to talk about what you need. I gave out reviews earlier this week. I don't know if you have it somewhere.
I need a pencil.
Huh? Maybe I just got thinner, okay?
Oh my God, thank you so much, Jason. You're so helpful.
Sine theta is 3 over 4. Now, what does sine represent? Y over r. So I got x, y, and r. Because this is single angle, I could just use x, y, and r. So the known value, sine is y. So that's 3. My r value is 4. And so I'm still missing the x. Pythagorean Theorem. X squared plus 3 squared equals 4 squared. So x squared plus 9 equals 16. Subtract 9 from both sides, so I get x is equal to the plus or minus square root of, yep. So I did skip a couple steps there because I'm pretty sure we've been doing this since week 1 of this course, and I'm hoping you could do this at this point. Now, it says that theta is in quadrant 2. What do we know about the x value in quadrant 2? It's negative. It's negative. So that's going to tell me that this is going to be a negative rad 7. And I'm looking for tangent theta. We know tangent represents y over x. If you don't know that, it's on the reference sheet, right? So, tangent theta y over x. So my y value is going to be, my x is negative rad 7. Do I leave it like that? No. What's that called? Got to rationalize. And so it's going to be rad 7 over rad 7, which is going to give me a negative 3 rad 7 all over 7. My answer is letra B. Letra B. Yep, right? Okay, let's keep going. Number 2. Find this on your reference sheet, please. Write me out. Write me out. Find that on your reference sheet. What are you waiting? Did we find it on the reference sheet? Is this a Pythagorean identity? So what's the one thing that's missing? So 1 plus tangent squared is equal to secant squared, right? Right there on my Pythagorean identities. Now, this one right here, are they single angles? Say yes. If they're single angles, they could be turned into x, y's, and r's. So what I'm going to do with this is I'm going to turn this into x, y's, and r's. So what does sine represent? Y over, and in this case, my r values are always very good. So I get y over 1 divided by, what is tangent? Y over x, right? Y over x, and I don't like that. Why do I not like that? Fraction over fraction, right? So I'm going to multiply by the reciprocal of the bottom. So that's going to turn into y over 1 times x over y. And something magic happens here. Cancel out those y's. I have a y on top and y bottom, and so what am I left with? X over 1, And if I translate that back into trigonometry, that turns into... Está muy fácil? Sí, sí. Muy fácil. Now, let's keep going. Number 4. Write the expression terms sine, cosine, simplify, so that no quotient. So I'm going to start off by translating in this into x, y's, and r's. So, cosecant. What does cosecant represent? 1 over y. Very good. It's 1 over y times cotangent. What is cotangent? X over y. Very good. So x over y. And the bottom of this says secant. And that is 1 over x. Very good. I do not like it. I do not like it here or there. I do not like it anywhere because this is a fraction over fraction. But what I am going to do is I'm going to do the top. So let's at least multiply the top. So on top I should come up with, very good, x over y squared times the reciprocal. So I'm going to flip over the bottom. What's that going to turn into? X over 1. Now on the top of this, I'm going to get x squared over y squared. Very good. X squared over y squared turns into cotangent squared. Very good. Yep. Okay. Again, this is another one where I'm going to translate it so I could do my math. So this says sine squared. What am I going to replace sine with? Y over r, or y over 1, right? So since it's sine squared, it's y squared over 1. And just so you know, that 1 is also square, right? What is 1 squared? It's still 1. So, right there. Now, cotangent. What is cotangent? I heard it. Very good. So it's x over y, and since it's cotangent squared, they're both squared, right? Plus 1. Más uno. Right? So right here, I'm going to do distribution. So I'm going to distribute here. When I distribute, what's going to happen to my y squareds right here? The y squared, I have a y squared on top and a y squared on bottom. So those are going to cancel. So what am I going to be left with here? X squared, right? Okay. So I get x squared there, or x squared over 1, if that helps you out. Now, I'm distributing to the next one over here. When I distribute over there, what am I going to end up getting? Y squared, right? So it's a plus y squared over 1. Now, this is where that little light bulb comes on. You're like, whoa, what is that? What is it? It is an identity I'm left with.
It equals 1.
1, there we go. Just comes out to be 1. Because x squared plus y squared is always equal to just 1. 1. There we go. Yes, no, maybe? Okay. Number 6. Same thing. I get 1 over, now cosine. How would I write cosine? X squared over 1, or since I don't need the over 1 here, so I'm just going to put it as x squared. There's a reason why. I would put over 1 if I needed to try and clean up a fraction over fraction. But in this case I don't, because I just have 1 on top, x squared on bottom. Okay, so I'm going to leave that like there. But now minus the other side, 1 over cotangent. What do we say cotangent is? X over y, but it's cotangent squared. X squared over y squared. So I'm going to take this over here and that piece right there. Do I like it? No. It's fraction over fraction again, isn't it? Fraction over fraction, so I need to clean that up. So I'm going to multiply by the reciprocal of the bottom. One times the reciprocal turns into y squared over x squared, right? And what is, that's just going to be y squared over x squared, right? Because it's times 1. Good. Let's bring it back down. So I now have 1 over x squared minus y squared over x squared. Just do that. What? Oh. Do I have common denominator? Yes, I do. So it's going to look like 1 minus y squared over x squared. Now, right there, you should have this itch in your brain that says, whoa, I remember Pacho saying something about that. What is 1 minus y squared? X squared. Very good. That's x squared. That's using my Pythagorean identity, which I will do it right here. Equals 1. And so it's subtract y squared. X squared is equal to 1 minus y squared. So I'm going to replace this whole top with x squared. And the bottom is still just x squared. And what happens there? 1. I cancel it out and I get just 1. And the answer is letra A. Does that make sense or nonsense? Okay, good. 7. Use identities to find the exact value. Yeah, I'm going to call this the Aldo. Because all you have to do is know how to use your calculator. Plug in the cosine to 255. Yep, and it's got, calculator's got to be in what mode? Yeah. So I'm going to, you said cosine 255.
Negative.
And degrees, right? I hit enter. That's my answer, right? Yeah? Now, to finish up the Aldo, what do I do? No, not make it a fraction. Plug in your answers too. And you're matching it. So I'm plugging in the answers. So the first one is rad 6 minus rad 2. Is that the same? No. Rad 2 minus rad 6. Is that the same? No. And this other one is, let's see, so it's rad 2 minus rad 6 over 4.
Whoa, that's spot on. That's it. That's the culprit. Oh, we found him.
Yes, right? Ooh, yeah. All right, there we go. So my answer is this one here. So on my test, I would circle what? Now, for those people not really trying to do this right now on your calculator, if you come at me on the test and say, hey, I'm not getting the answer. I don't know how to put it to the calculator. we've been doing this for, let me see, we're coming up on at least, this is week 7 of this semester, of the second semester of using this calculators. So if you still don't know how to do it, okay, you better try to figure out right now. Okay, this one, you could Aldo, or it's quicker to do it the real way. It's quicker to do it the real way. So I want to match this to one of my formulas. On my reference sheet, I'm going to match it to a formula. It says cosine, cosine, minus. So which one of the formulas on my reference sheet uses cosine, cosine, minus? S plus T? Is it on the double angles? Same. One of these, right? Oh, is it one of those? Nope, it's none of those. We've actually done everything but these top right here. Everything else we did already. So try to find it somewhere else. There it is. It says cosine, cosine, minus. Which one's cosine, cosine, minus? Cosine, cosine, minus. Cosine, cosine, minus. That gives you that. This is cosine, cosine, plus. That gives you that. So, we're adding the s and t. So this is cosine of s, which is 36. Plus t, which is 24. Add them, I get cosine of 60. And we know 60 is a value on my unit circle, which is... So cosine 60 is 1/2. All right? Nine. Now, if you go look at the formulas for tangent using sum of difference, aren't those ones ugly? So what do you think would be easier to do? Wow. That did not want to work very well. So if you're doing the Aldo, everyone currently, right now, at this moment in time, is doing the Aldo. Not just looking at me, not just playing on their phone.
Doing the Aldo.
And if you're getting something wrong, what's the first thing you need to check? Radian or degree. That's important. That's one of the bigger issues that a lot of people overlook. So hopefully everyone should be about done doing that right now. So so we said tangent of, what was it, 75? Okay. And then checking my work. Hey, look, there it is right there. So what option is that? That's option D, right? Number 10. What am I going to say on number 10?
Although. Whoa.
What answer did you get?
C.
Yep.
Oh.
Everyone get C?
It's the same answer as the last one. Cosine 255.
Oh.
It's the same answer.
Okay. Number 11. Now, this is going to be an easier one because I could either aldo it or I could actually do the math. I think the math is going to be easier on this one. Look at my reference sheet. Go find the sum and difference that says sine, cosine, plus. It's going to be a sine. Which one's this going to be? S plus t. S plus t. So I'm going to have sine, my s value, which is pi over 15, plus 4 pi over 15, sine of 5 pi over 15. That reduces to sine of okay, what is sine at pi over 3 though? We're at 3 over 2. So some of them it's quicker to do by hand, other ones it's quicker to do the aldo. Now, this one right here, go ahead, I'll do it.
What?
Oh, there it is. The over 1 got me. I'm like, wait a minute. Okay, did you guys get D? Okay, good. All right, these ones here, they are going to be a bit of work because you have to find your X, Y's, and R's. These ones you have to get your X, Y's, and R's before you do anything. So, let's see. We have two angles. We have an S and we have a T. So my S is going to have an X, a Y, and an R. My T is going to have an X, a Y, and an R. So we're combining two angles together now. So for my S, my cosine S, what does cosine represent? X over R. Cosine represents X over R. So in this case, my X value is what? -1. My R value is? There we go. So what's missing? My Y value. So the Y value is missing. So I'm going to use Pythagorean Theorem. -1 squared plus Y squared equals 6 squared. So it's 1 plus Y squared is 36. Subtract 1, so Y is equal to plus or minus square root of 35. So yes, I combined some steps here because we've been doing the same thing since back in Unit 1. Now right here it says it's in quadrant 3. What do we know about the Y values in quadrant 3? Negatives. So this is going to be my negative. We're at 35. Now I need to do the same thing for my T's. Over here it says cosine T is -3 over 5. So cosine represents X over R. Cosine is X over R. So my X value here is -3. My R value is 5. So we're going to do the Pythagorean Theorem again. -3 squared plus Y squared equals 5 squared. 9 plus Y squared is 25. Y equals plus or minus the square root of, what do we get, 16? Yeah? Hopefully? 25 minus 9, 16? Yes? Okay, good. Now what is square root of 16? 4. And it says that T is in quadrant 3. So what do we know about the Y value in quadrant 3? It's negative, so that's a -4. Cross out? Oh, I guess I could because it says 37. That's kind of weird, right? All right, you guys ready at least? So I'm going to do my formula now. It says we're trying to find cosine of S plus T. I'm using some more paper on this one. So cosine of S plus T. So cosine of S plus T, so that's cosine of S, cosine of T, minus sine of S, sine of T, right? And we're going to use those X, Y's, and R's that we just had. We're going to use those X, Y's, and R's to plug in for cosine of S. So cosine of S was that -1 over 6? Cosine of T. Very good, thank you. Minus sine of S. We're at 35 over 6. Yes? Sine of T, -4 over 5. Does anyone have questions on this or where they're coming from or why? This formula is on my reference sheet. It is on my reference sheet here. Now we just need to do some multiplication here. So on the first one, negative is going to make a positive. 1 times 3 is 3 over, what do we get there? 30? Okay. Now, minus. So again, a negative, but I have a rad 35 times a 4. So those don't go together unless I have another rad. So that's going to be negative, negative, positive 4 rad 35 over 30. And then combining it over one denominator. So 3 minus 4 rad 35. 3 minus rad 30. Right here, B. Is that the answer right there?
Oh, wait.
3 minus 4 rad 35, right? All over 30. Okay. Questions, concerns, complaints? Okay. There we go. 14. Now it's another one. This one's gonna look ugly, doesn't it? It looks ugly. But it will work. We're going to find sine of s plus t. So again, we have two separate angles. So I have angle s, and that's x, y, and r because they're all single angles. So here cosine is negative 12 over 13. So my x value here is negative 12. My y value is, don't know yet, but r is 13. T, this one, ooh, bless you. Sounded juicy. Man, don't you hate it when it's like those really bad, oh my goodness, bad juicy ones? You're like, man, that was so juicy. You look around to see if it landed anywhere. Yeah. Don't act like you've never done that. You're like, oh man, that was so juicy. Where'd it go?
How does sneeze be juicy? What does that even mean?
It's like you spray all over. Yeah.
Spray everywhere.
It's a sneeze.
That's sick.
It's a sneeze.
Oh, it's a you're a sneeze.
Either. But it's like, it's so juicy. It's like, it's all over. Like, you should have worn a bib for that one. Yeah. All right. So now, in this case right here, do we know x? No. Do we know y? What do we get? 8, and the r value is? There we go. So I'm going to have to do Pythagorean Theorem again to find my missing variables. So I have negative 12 squared plus y squared equals 13 squared. So 144 plus y squared is equal to 169. Subtract, I get y is equal to plus or minus the square root of 25. What is square root of 25? 5. Okay, so now it's still plus or minus, isn't it? So it says that S is in quadrant 2. What do we know about the y value in quadrant 2? Positive. So that's a positive 5 here. Now we got to do it again. So I have x squared plus 8 squared equals 17 squared. So x squared plus 64 equals 289? Yeah. So a little bit of math. X equals plus or minus the square root of 225. Yes. It is 15. Now, right here it says for my x, and it says x is in, or my t value is in quadrant 2. So what do we know about the x value in quadrant 2? Positive, negative? Negative. So it's going to be a negative 15, right? So it's a negative 15. So I'm going to go to my next page because I'm going to do the sine of s plus t. And if you guys need scratch paper, this whole basket here is scratch paper. So let's see. I'm going to have sine of s plus t is sine of s cosine of t plus sine of t cosine of s. Right? Alright, so go ahead and start plugging in. So sine of s, what do we come up with sine of s? 5 over 13. Cosine of t? Negative plus sine of t? 8 over 13? 17? Okay. And cosine s? There we go. And if you're really not feeling froggy with your fractions here, from here you could just Aldo. Because I have no radicals, right? The calculator will spit it out and just do everything for you. But it might be quicker to just do it by hand.
Do you have to put in parentheses?
Yeah, that would work. I put in parentheses because it keeps track of your negatives and it helps you keep everything together. So let me see. That's going to be negative 75 over 8. No. Huh? 221? Plus, what's that? Negative 96 over, and since they're both negative, it's going to give me a bigger negative, is going to be, what's that going to be? 71? 171, so negative 171 over 221.
Also, with the calculator, we don't have to do that extra step.
If you just plugged in the calculator, that's all you got. So your final answer. I still did it by hand though.
On the seven identities, how do you know if you use the top or the bottom one?
Okay, so is it say s plus t or does it say s minus t?
They both say s plus t.
No, they don't.
Sin s plus t, cos s plus t.
Okay, so which one are you using?
Sin.
Oh.
But yeah, but I don't know why.
Okay, the question originally said you're finding what?
That one. But then, oh, okay,
Sure.
so it. I get what you're saying.
Yeah, right here, and this one down here.
So if the
is-
question asks specifically for that
Yeah.
one, you go for
Yeah,
that.
you just go that way. Does that make sense?
Yeah.
Okay. All right. Any what was my answer? So D. Yes. I'm just seeing who's paying attention. Got like 4 people that caught that, but no one else. Everyone's just playing on their phone, right? Mm-hmm. There we go. Fitting. Fitting. So it says sine of x minus pi over 2. So x minus pi over 2, that's going to be, nope, and s minus t. S minus t, right? Because in between there's a minus sign. Yeah?
Correct.
Okay, good. So let's do that one. So that's going to be sine of s cosine of t minus sine of t cosine of s. Now, in this case, sine of s, so my s is sine of x, this is cosine of pi over 2 minus sine at pi over 2 cosine of x. These ones clean up to be pretty clean here. Now, what is cosine of pi over 2? Cosine of pi over 2. Yeah. 0 times my sine of x minus, what is sine at pi over 2? 1 times cosine of x. So anything times 0 is 0. So this goes away, and I'm left with the answer of -1 cosine of x. And that's going to be
Wait, but mister, so how do you know? Like, because it doesn't say, like, S minus T.
it says using a,
Oh, okay.
yeah, it says right there. So if you're looking at 15 on your paper, I copied and pasted it with the instructions. So look at your paper. It is there. It's right above it where it says sum and difference. So that tells you what you're going to use. All right? What do you think I'm going to say? And for those people playing along at home, I'll do it by hand too. Are we good? Or no? So this one is a little bit longer doing it on the calculator than it is to do it using the references. I went and found it. It is a double angle for tangent. It's a double angle for tangent. I went and found that. Plugged in the 15. That replaced my 2 theta or my 2s or 2t, whichever it has. All right, and my answer has to be C. All right, anyone questions there, or are you still working on it? Okay, because your tangent squared. Okay, this. Okay, the problem is your tangent square goes on the outside. Otherwise, you take it. Yeah. Okay. All right. Anyone else have that problem, or are they just playing with their phone instead? What was the problem on this one that you were probably having? Where's the square go?
On the
Outside. It doesn't say tangent with the square, then your angle. It goes outside your parentheses of your angle. All right. This right here is 17. It's giving me a tangent of a single angle. So if it's single angle, I know that has to be my x, y, and r, right? So, tangent, x, y, r. So, tangent is normally, what is tangent? Y over x. So my y value here is 21. My x value is 20. R is, I don't know yet. Let me see. So 20 squared plus 21 squared equals r squared. So that's going to be 400 plus 441 equals r squared. 841 is r squared. R is equal to plus or minus the square root of 841. Now, can r be negative? No. It can't be negative, so I know it has to be positive. And I'm going to leave it as in the radical for right now. I'm going to leave it in the radical because you'll see why here in a moment. Says right here that I'm looking for sine of 2 theta. Okay. And it also said that my theta is between pi and 3 pi over 2. Pi and 3 pi over 2. So what quadrant is that? 3. What do I know about the x and y in quadrant 3? So, right here, this is a negative 20 and a negative 21. It doesn't affect my r value right now, but when I go in and plug in my problems, it will affect. So we're trying to find sine of 2 theta. So I go find my reference sheet, sine of a double angle. So it's going to say sine of 2 theta is equal to 2 sine theta cosine theta, right? That should be the top of my double angles. So on the reference sheet, the back side, the very top. Yes. So I'm going to plug in my single angles. 2 sine of theta is going to be negative 21 over radical 841 times cosine, which is going to be negative 20 over radical 841. Okay, you guys ready? Why am I not worrying about my r values here? Why am I not worrying about my r values being a radical? I got rad 841 times rad 841 on the bottom. What's going to happen to my radical there? Goes away. So on the bottom I get 841, but on the top, let me see, what do I multiply that out? Negative, negative, positive 840? Is that right? Yes?
41 times 20?
2 times 40, so it's 2 times negative 21 times negative 20. Yes? Okay. B? There we go. All right, let's keep going. 18. What am I going to say here?
I'll go.
So I know you people are plugging this in because this is going to be a crazy one that's going to mess it up. And I'm almost positive some of y'all are going to input it incorrectly.
Whoa. You're almost positive? What percentage is that?
Now, if my winning this bet is some of you getting it wrong, I have a very high percentage on that. If my winning this, everyone gets it wrong, a very low percentage.
How about if I get it right, we don't take the test?
There is no possibility of doing that.
Oh, I got it right. Oh, no, I didn't.
All right, what did we get? Huh?
Whoa.
Did it.
Can't say no on us. Jay already proved it.
No.
Didn't he? Yeah, we will check. Look, let me hit that red flag right there. Okay, instant replay. Instant replay.
I was still working.
You already said that he was wrong.
I thought it was something else.
Now, this one right here. Yes.
I actually got it wrong.
I got
Oh,
it.
okay, good. So that's all I was waiting for. Someone to ask me how to do it. Instead of just being one of those people.
How do you not all do it? How do you do it by hand?
Cosine 75, right? Yes? Okay, cosine 75 is this. Now, I'm going to start with my fraction. The 1/2 that was out front, right? Control, divide. My 1/2 is out front. Arrow over. And now I got my radical. So control, x squared. Okay. So that's how I get that. And was it 2 minus rad 3?
Oh, yeah.
Like that, right? And so when I hit enter, I get the same answer.
So how do you like put it all in?
Yeah, you put them all in until you get the right answer. And that's why I said you have to go through. It's a bit of a longer process, but it's the correct answer is there. All right, 19. This one right here, again, is a single angle given sine, which is my x, y, and r. So sine is y over r, so my y value is 1, my r value is 4. X squared plus 1 squared equals 4 squared. I'm going to do, so it's x squared plus 1 equals 16. X equals plus or minus the square root of 50. And says this one is in what quadrant? So in between 0 and
Quadrant 1.
pi over 2 is quadrant 1, isn't it? So what do we know about my x value in quadrant 1? Positive. Good. Now, it says find sine of a half angle. Okay. Sine of x over 2 is equal to plus or minus the square root of 1 minus cosine of x divided by 2. That's the formula, okay? That's the formula there. So we got to start plugging some stuff in. Now, this is in quadrant 1, So what do we know about the plus or minus? It's going to be positive, right? It's all in quadrant 1, so it's positive. So I can get rid of that. So my answer is going to look something like this. 1 minus. Now cosine, given that, is going to be rad 15 over 4. All that is divided by 2. All right, you people ready now? No?
Ready for what?
It's kind of a mess, isn't it?
Yeah.
It's kind of a mess.
Sure.
And so, watch this. I'm going to try and make this as easy as possible. Why are we going to Aldo from right there? Because, yeah, we can, but we had to plug in my cosine. So I had to find the x, y's, and r's. And once I got it down to only numbers, then any of those problems that have only numbers, you just plug it in. So this is going to be what you're plugging in, and your multiple choice is what you're testing. So y'all are plugged in right now, right?
Okay.
The magic of a multiple choice test. All right, for those people still struggling, it should look like this. All right, so what was my answer here?
C.
C?
C.
All right, there we go. And number 20. Now, you can if you want to. It's, in my opinion, it would be easier just to look to see which one's I'm using.
Oh, it's using.
It's a half angle for what? For sine. Half angle sine. So my A value in this case is 28. You could have aldoed it also, but just matching it to my reference sheet and working backwards towards this. So my answer comes out to be B. All right, don't forget, like, share, subscribe, hit that notification button, and buy my socks. Yes, what you want?